Hey everyone, in this video I'm going to do a quick tutorial about PyTorch. Start with the new notebook. I'm going to use, by the way, I'm going to use Google Colab for this video. First thing you need to do is set up, I'm going to change it to GPU instead of CPU. And then we're going to check what kind of a GPU. So I'm going to use NVIDIA. Let me zoom in a little bit. Okay. I want to make sure it's in the frame. So this is a command to check the GPU. So seems correct. CUDA version is 12.2 and using a Tesla T4, and if you subscribe to the Pro, you can get better, you have access to the better GPUs. So but we're going to use this for this example. This should be fine. We're going to use this. Basically in this video what I want to cover is the PyTorch tensor data types and some basic operations with tensors. And so yeah, that's about it. And creating, manipulating tensors and autograd, using gradients for optimization. What else I want to cover? Functions and attributes and operations. We need to import Torch, PyTorch, obviously, and let's check the version of the PyTorch. The CUDA CU basically means CUDA version, and NVIDIA CUDA 12.1 and PyTorch version 2.1.0. So let's do some basic stuff. Okay, but we're gonna import a few more. Pandas SPD, SNP. I think this should be it. This should be enough for this tutorial. Okay. Let's go over the data types first. And here are the types that you can store. So tensors are quite important when you want to learn PyTorch, because they are the fundamental building blocks used for representing data in deep learning and other numerical computations. So the term the tensor is the generalization of the concept of basically scalars, vectors, and over each one of them. So tensors can be basically zero dimensional, which is a scalar, one dimension, which is vector, and two or more dimensions called matrix. So the number of the dimensions is often referred to as the rank of the tensor. And we went over the data types and operations. The tensors support a wide range of operations, including mathematical operations like addition, multiplication, also linear algebra operations like matrix multiplication, and other specialized operations that are used in machine learning. So tensors also provide a flexible way to represent and manipulate data in various forms. We're going to go over that briefly and some examples. Also, backward propagation. So in deep learning frameworks like PyTorch, tensors are central to implementation of automatic differentiation, which is actually crucial for training neural networks using techniques like gradient descent. And tensors allow, I won't cover gradient descent in this video, but if you're interested, please let me know. I will cover in the future. So tensors allow the tracking of the gradients, forward pass, and subsequent backward propagation. Maybe I'll cover the basics. We'll see. Let's start with the simple example. Like I said, for zero-dimensional is called scalar. So let's start with the scalar example. So torch dot tensor. Let's give it a value 3.1415, I think. Yeah, whatever, it doesn't matter. And then we can print the value of the tensor, which we can also check the dimension here by calling .ndim. That will check the dimension. Should be 0 because it's a scalar. So the tensor, see, dimensional 0. Tensor, let's do one dimension example. So let's call it x dot tensor, basically one-dimensional array. And then we can do basics operations using, for example, x plus 5, multiplication, addition, subtraction, all kinds of basic stuff we can do with tensor. Okay, and we can also use built-in functions like square the value of y, and then we're going to print x y z. Alright, let's see. So this is basically a basic operation. We can check here. DIM dimension. You can use print, or you don't have to use print, doesn't matter. Here's one dimension. Okay. So let's go over automatic differentiation, also known as autograd. Autograd is a critical feature that allows PyTorch to automatically compute gradients during the backward pass, enabling gradient-based optimization for training neural networks. So gradients in PyTorch represent the rate of change of a tensor with respect to some other tensor. So in the context of neural networks, gradients are kind of crucial for performing optimization, where the goal is to adjust the model parameters to minimize or maximize a given objective function. Just go over some simple examples for this. So if you want to create a tensor with the gradient, can do this by torch tensor, and let's give it a value 2 and then require grad. That's basically will create a tensor with require grad. So okay, let's do a forward parse. So this is how you do basically basic operation, like something like this: square plus whatever 3. This is called forward parse. And the backward parse is just backward. This is the backward parse. And this is how you access the gradients. Next, let's compare the two. So here it went back to here. Okay, also you can do detach from the tensor for operations not to be tracked. It will get clear like once we do more examples and applications in the future, but right now it's just let's go over some operations. Detach. So this will detach the, so let's print it out. Grad and so here after detaching it's none. Okay, so we went over the autograd forward autograd and during backward parse. Okay, let's do some gradients for optimizations. So let's do some optimizations. Okay, we're gonna use the same x, and then we're gonna do define quadratic function return. Let's say a squared minus 4x 4x plus 4. Let's do some quadratic function and then do a optimization. Optimizer, let's call it optimizer torch dot optim gd x comma, let's give it 0.1. Okay, and then fall in range 100. Let's do optimizer dot 0 grad, then output quadratic function. I need to disable this typing thing. I'll do this later. It's becoming annoying. Nicer step. Okay, now we're gonna print the optimized value of x. So basically x dot item. Oh, spelling is wrong. Okay, should work. function quadratic function. Does it look correct? Let's run it. Just copy it. I cannot type today. X. Okay, so here's the optimized value of x, which is 2. Maybe we'll do a neural network training scenario in next video. Let's do simple stuff for this video. Let's go over random tensors. This one, the PyTorch random tensor, basically returns a tensor filled with random numbers. So let's do this. So how do you define random? Let's go float tensor equal to torch dot ran 3x3, and we can print floats. Tensor, okay, should print 3x3 random tensor. This is like a default. I think the default data type. The 32-bit float. Okay, let's do integer example 2x2. We did 3x3, so let's do integer 2x2. Then int tensor torch to rand int. So let's do this time from 0 to 9 here. For 0 to 9 we have to go up, we have to give 10. So 0 to 9. Two by two. So as you can see, up to 9 from zeros. Okay, let's do another example. This time let's do a normal distribution with the mean of 0 and standard deviation of 1, which is basically a default. So this is actually the same, the default, but we have for normal distribution we're gonna have to call different so here's the normal distribution. Let's call it normal tensor, basically torch dn 3x3. So here returns a random number from a normal distribution with mean and the variance, which is the standard deviation, standard normal distribution of 1. So this is that example. Distribution with mean 0 and standard deviation 1. Let's do another one more, I guess, for random. This time let's do the permutations. Example, random permutations to be exact. I cover these because these are quite useful in the future, you will see. So this is Torch random permutation. Returns the permutation integers from 0 to n-1. So let's go over this. Let's call indices rand perm 0 to 5. So we have to go n-1. Print indices. So it will generate random permutations here. Okay, let's cover functions and attributes. Also, I want to compare it with the NumPy. So functions basically perform operations on tensors and transforming them into new tensors. So let's go over NumPy first. Bear with me if you are like, I want to show some similarities. This is how you do a matrix multiplication. I'm going to use a matrix multiplication as an example in NumPy. So basically I'm going to use two-dimensional array. 2, 3, 4, 5, 1, 2, 3, 4, and 5, 6, 7, 8. Just make it simple. 5, 6, 7, 8. Let's perform a multiplication, matrix multiplication. Result of the NumPy. I'm going to compare with. So in NumPy we use dot for matrix multiplication. B. Then we're going to print the results. Results and results P. Oh crap. Here should work. Oh. Okay, so this is the matrix multiplication in NumPy, and let's do the same operation using PyTorch by creating tensors. In PyTorch the data type is tensor, so we're gonna call it tensor A, which is we're gonna use the same. Instead of NumPy array, we have to change it to PyTorch tensor for the data type for NumPy. Okay, now let's do B. Just copy and paste. Okay, so we now have two tensors. We're gonna do a matrix multiplication using PyTorch. This is result torch. So we in torch just call it for matrix multiplication, and then tensor A and tensor B. Then we're gonna print PyTorch results. Okay, should be the same. So this is the same operation, one using, just want to show you some of the similarities between NumPy and PyTorch. And I want to show you some more example that's, it's pretty similar to normal operations in Python, but using tensor and PyTorch. As we can do indexing, slicings. Okay, let's go over that. Let's start with some indexing. So let's create a tensor. Let's do 1, 2, 0, 1, 2, 3, 4, 5, I guess. Okay, so same way we access. If we want to access first element, what we do is tensor 0. This should print the first element. So this is a pretty straightforward way. If just change it to tensor, so let's do more indexing examples. Let's do the same thing if we want last element as we do in normal indexing in Python, like -1 will give you the last element, tensor 5. And let's do one more example. So if we want to use the index number 2, index 2, same thing. I mean, same as a normal way of doing in Python. This is pretty straightforward. It's a tensor 2, 0, 1, 2. Okay, so let's do some slicing. Same way we do in Python. Don't need to redefine. So we want the slice from index 1, 2, 3, 0, 1, 2, 3. Okay, so same thing as we do in Python. index 1, 2, 3. Zero, 1, 2, 3. So 3 is excluded. And let's do the slicing from the beginning to the index 4, also exclusive of the 4. So this should print up to 3. Okay, let's do another example. This time let's do the index 2 to the end. And so this should be pretty straightforward as for Python. So starting from 2, 0, 1, 2, all the way to the end. Okay, let's do the stepping. Let's skip every other element. So I'm gonna go 0, skip 1, so 2, and skip 3, 4. Let's skip every other element. 2. So 0, 2, and 4. Okay, what else should I cover in this video? Alright, last one. Let's do a multidimensional. So this is like a attribute example also, not just a multidimensional. So we went over the functions, and now it's like attributes. So these examples are like how to access using attributes. And let's do the last one for we're gonna use the multidimensional this time. Matrix. Yeah, let's call it matrix, why not? Tensor. We're gonna do a 3-dimensional this time because we wanna do okay. Let's do 3 by 3 dimension. 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9. So let's access the first. Oh no, let's do the specific element first in a 2D tensor. So let's get the matrix from row 1 and column 2. And let's do this first. Let's access the row 1 and column 2. So matrix 1, row 1, and column 2. So this is row 0, this is row 1, this is row 2. So this is row 1, and this is column 0 is 1, 4, and 7. Column 1 is 2, 5, and 8, and the column 2 is 3, 6, and 9. So we should get number 6. So we get the tensor number 6. Let's slice the first row. Like after this, if you're new, you should practice these. So this will help you a lot when you do the PyTorch. So let's slice the first row. So this is row 0, 1, 2. So we're gonna slice the first row. So this is the first row, 1, 2, 3. Let's do one more. Let's slice the column this time. Let's slice the column 1. So column 0 is 1, 4, and 7. Column 1 is 2, 5, and 8. Let's slice that. Matrix. And then we're gonna slice column. This is row. This is column 1. Pretty straightforward. So here's the column 0, 1, 2, 5, and 8. Okay, one more, and then we're gonna call it. So we're gonna do slice a submatrix row 1 from row 1 to column 1. So from 3 by 3 we're gonna get 2 by 2. Basically, we're gonna take out. We're gonna slice from row 1. So row 1 is not. Row 0 is not included, and the column 0 is not included. So basically, tricks. So we sliced from row 1. So 1, 2, 3 is not included, and column 1, 1, 4, and 7 is not included. So we have 5, 6, and 8, 9. So yeah, if you're gonna work with the PyTorch, this like practice these are like fundamentals operations, and I'll cover more in the future if you are interested. So I guess that's it, and thanks.